about reaction rates. Now we're going to talk about factors that affect reaction rates. And there are about 5 of them, so we're going to look at them one at a time. So first of all, the chemical nature of the reactants affect reaction rates. So for example, as you move down the alkali metals, and don't forget the alkali metals are, if this is the periodic table, alkali metals are here, right? And so we're going to look at lithium is here, sodium is right beneath it, and then potassium is here. And so we're going to look at a video, nice video here done by Scott Milam, who is going to show us that potassium burns the fastest of these 3. So I've got the video already queued up over here. Let's go here and watch this. Here's lithium, here's sodium, and here's potassium. I'm just going to let him describe this.
Here I'm working with some lithium metal, very difficult to cut. I've got a piece of sodium here, pretty easy to cut. You notice when I cut through that the fresh sodium is very shiny compared to the rest. Let's zoom in real quick and see if we can really get in there. So this side will reflect a lot of light. The other sides are pretty dull. And you'll see that especially with the potassium here. I'm going to go ahead and give this kind of a half cut. So for the potassium, this is the side that's freshly cut, and you can see the dullness to the other sides compared to that one. So I'm going to go ahead and take those 3 and I'm going to add them to water, and we can look at the kind of reactivity of those 3 alkali metals with water. So here I'm going to take the lithium and add that to the water. It's going to generate hydrogen gas and lithium hydroxide. So you're going to see a pink color develop here, and then you're going to see some smoke come off, and that's either lithium metal or that's lithium hydroxide coming off of there. Maybe a little bit of liquid water. But it's not as reactive as, say, sodium, so I'm going to put sodium into the next one. And the sodium is actually probably going to ignite. So you'll see some orange flame perhaps, or some sparks, or some shrapnel. And then the last one, I'm going to go ahead and put my 2 pieces of potassium in that I've cut in half. So this is less potassium than the other 2 in terms of amount. You'll find that the reactivity is a little bit greater.
Okay, so we see that potassium reacted the fastest, and sodium was the next fastest, or the next most vigorous, and lithium was the least. And that's because, well, we don't actually get into why, but it just turns out the chemical nature of the reactants sometimes affects the reaction rates, okay? The second thing that affects reaction rates is the state of subdivision of the reactants. The reactants with the increasing surface area make faster reactions, okay? So here you've got some finely divided powder. It's a little difficult to see. You get some finely divided powder, and you can see you've got bubbles forming pretty well. And so there's lots of interaction between the water molecules and the powder. Over here, we do not have as much interaction. You see it's not mixed in as well. And so you're not getting, there are some fine bubbles in there, but you're not getting as many. The reaction's not as fast because we don't have as much interaction. That is, the surface area is lower between the 2 reactants in this reaction. So the state of subdivision of the reactants is a second factor that affects reaction rate. A third factor is the temperature of the reactants. So usually increase in temperature increases the reaction rate, okay? Rate ordinarily increases with the temperature, and rate normally increases with the concentration, right? So temperature, concentration, and then finally a catalyst, which we won't describe here why a catalyst affects the reaction rate, but that is another thing that affects the reaction rate, okay? So chemical reactions occur as the result, this is really interesting, chemical reactions occur as the result of collisions between reactant molecules, and that's why these things would matter, right? So the higher concentration of reactant molecules, the higher concentration, you find that more molecules are likely to collide and to react. So in the interest of time, I'm not going to show you this one, but I'll put it there, and you can look that up. I don't think this is clickable on my video, but it's a neat video of someone burning phosphorus in pure oxygen, right? So pure oxygen means, the air that we breathe is not pure oxygen. There's actually like 70% of it is nitrogen, which is unreactive. So if you want to burn something in regular air, the air that we breathe, it doesn't burn very fast. But if you take, in this video, the scientist takes pure phosphorus and burns it in pure oxygen, and it burns really fast. So as reactants get consumed, collisions happen less frequently, and the reaction rate decreases, also shown very nicely in this video. Okay, so the 5 factors are the nature of reactants, the state of subdivision, the temperature, the concentration, and the presence of a catalyst. All right, hope that's helpful.